Jack Donaghy has the following supply and demand functions for a new artifact. He wants to know the price and quantity sold at equilibrium, the producer and consumer surplus, and the total surplus at equilibrium. Our first task is to find the price and quantity at equilibrium. This can be found by setting the price received by suppliers equals to the price paid by consumers. In other words, Q plus 5 squared must be equals to 9 minus Q squared. Here we can expand these functions. This is Q squared plus 2 times 5, which is 10, Q plus 5 squared, which is 25, equals to 9 squared, which is 81, minus 2 times 9, which is 18, Q plus Q squared. Here we can cancel Q squared and Q squared, and we get 10 plus 18 is 28Q equals 81 minus 25 is 56, which means that quantity at equilibrium must be 2. In order to obtain the price at equilibrium, we can replace this Q in the supply or the demand. Let's replace it on the supply. This is 2 plus 5 squared, and therefore our price at equilibrium is 49. Our second task is to find the producer and consumer surplus. To find the producer surplus, we use this formula. Price times quantity at equilibrium minus the integration of the inverse supply with respect to Q. This is equals to price at equilibrium, which is 49, times quantity at equilibrium, which is 2, minus the integration from 0 to quantity at equilibrium, which is 2. Here the inverse supply is Q plus 5 square dq. Here there are a couple of ways that we can obtain Q plus 5 square. But the easiest one is to use U substitution. In order to use integration by substitution, or also called U substitution, we need to identify which factor will be our U. In this case, we have two factors, Q plus 5 squared times dq. In this case, the most complex function is Q plus 5 squared. Therefore, our U will be Q plus 5. This means that the derivative of U with respect to Q is simply equals to 1. In other words, dq is equals to du. Now let's find the new boundaries. Here we have that q goes from 0 to 2. This means that now u is equals to 0 plus 5 is 5. So this is the lower bound for u. 2 u equals 2. 2 plus 5 is 7. Now let's change everything in terms of u. Here the integral in terms of u is let's start with the integration sign. The domain goes from 5 to 7. Q plus 5 is our u square, and then dq is equals to du. Now that we have our integral in terms of u, we can proceed with the integration. The integral of u squared is u to the third divided by 3. And this goes from u equals to 5 to u equals to 7. This is equals to 7 to the third divided by 3 minus 5 to the third divided by 3. 343 minus 125 is 218, and everything divided by 3, which is approximately 72.67. This means that this integration is equals to 72.67. Let's replace this numerical value here. So we had 49 times 2 is equals to 98. And this integration results in this numerical value, 72.67, which is equals to 25.33. This means that the producer surplus is 25.33. To understand what this number means, let's graph the producer surplus. First, we need the inverse supply. When Q is 0, the price will be 5 squared, which is 25. Then, because this is a quadratic function, this will be a parabola. And you can see that it will be Q squared. Therefore, this will be actually with this shape. And then we graph the price and quantity at equilibrium. This was 49 and 2. The producer surplus is the area below the price but above the supply curve. So this number 25.33 represents this area. Now let's find the consumer surplus. This is equals to the integration of the inverse demand minus the price and quantity at equilibrium. This is equals to the integration from 0 to 2 of the inverse demand, which is 9 minus q squared dq minus 49 times 2. We need to find this integration. And the easiest method that we can use is U substitution or integration by substitution. Here we have 9 minus q squared times dq. Here we can see that the most complex function is 9 minus q and everything squared. Therefore, this will be our u. Let's take the derivative with respect to q. This is equals to negative 1. In other words, dq is equals to negative du. Now let's find the boundaries for u. First we have q equals to 0 to q equals to 2. Here we have 9 minus 0 is 9. And here we have 9 minus 2 is 7. Here we have to notice something pretty interesting. Our lower bound will be 9, whereas our upper bound will be 7. This is because the particular function, because u is equals to 9 minus q, which means that when q increases, the value of u decreases. Now let's substitute everything to make this integral be a function of only u. Let's start with the integration. Notice that we go from 9 to 7. Then 9 minus q is our u, which is a square, and dq is equals to negative du. Let's move this negative to the front. So we have here u squared du from 9 to 7. This is the integration of u to the third divided by 3. From u equals to 9 to u equals to 7. This is negative 7 to the third divided by 3 minus 9 to the third divided by 3. This is minus 386 divided by 3, which is about positive 128.67. In other words, this integral is equals to 128.67. Let's substitute this value in the previous page. The value of this integration was equals to 128.67 minus 49 times 2 is 98. So this is equals to 30.67. And this is our consumer surplus. In order to interpret this number, let's graph the consumer surplus. To graph the consumer surplus, we need the inverse demand. When Q is equals to 0, the price is 9 squared, which is 81. And because it's a quadratic function, this is a parabola. When the price was 49, the quantity was equals to 2. The area below the demand but above the price is the consumer surplus. Which in this case is 30.67. In the last task, we need to find total surplus. And there are two ways that we can find total surplus. The first one is by recognizing graphically what is total surplus. The total surplus is the combination of the areas between the consumer surplus and the producer surplus. Notice that in this case, we already obtained those values. A second way is using the area between the curves. In this case, the total surplus is the area between the demand and the supply. Therefore, if we use the area between the curves, we can directly obtain the total surplus. In this exercise, we will use that formulation. the area between curves. And we will compare if the answer that we obtain using this method will be equal to the value obtained by summing or adding the producer surplus plus the consumer surplus. In order to use the area between curves, we need to recognize which function is at the top. In this case is the demand, and supply is at the bottom. In other words, if we want to find this area, what we do is we will subtract the demand minus the supply, and we will integrate that area with respect to Q from 0 to the quantity at equilibrium. Let's replace these formulas. So here we have that the integration will go from 0 to 2. Here we have 9 minus Q squared minus Q plus 5 squared dq. Let's expand and simplify this expression. This is 81 minus 18Q plus Q squared minus Q squared minus 10Q minus 25 dq. Here we can cancel Q squared. And we obtain minus 18Q minus 10Q is minus 28Q. 81 minus 25 is plus 56. The integral of minus 28Q is minus 28Q squared divided by Q plus the integral of the constant 56 is 56Q from Q equals to 0 to Q equals to 2. Before we proceed with that, let's simplify a little bit. 28 divided by 2 is 14. When Q is equals to 2, we have 2 squared, which is 4. 4 times 14 is negative 56 plus 56 times 2 is 112 minus, if we substitute Q equals 0, the whole term is simply 0. This means that total surplus is equals to 112 minus 56 is 56. Now, let's use the first method. Total surplus is equals to producer surplus plus consumer surplus. Producer surplus was 25.33 plus consumer surplus was 30.67. Summing these two, we get that the total surplus is equals to 56. Therefore, as you can see, if you use any of these two methods, you will obtain the same answer. Therefore, total surplus is equals to 56.